Hello, this is Ratios Easy Maths with IITians. We are a group of IIT Kanpur alums who are in the pursuit of providing quality education to everyone. Through these videos, we will cover each topic focusing on basics so that one doesn't need to remember much. In the end, we will solve questions to make sure nothing stops you from scoring good marks, not only in school, but also in competitive exams like JEE, NEET, etc. We believe this is possible for anyone with the right approach and we want to do it with you. Let's go! In this video, I shall cover trigonometry, one among many age-old discoveries that came out of India. Trigonometry is about ratios. The functions which we define in trigonometry, sine, cos, tan, are all ratios of edges of a triangle. By simply exploiting the simple understandings of ratios, we can calculate things on paper which are close to impossible in practical life. We can calculate heights of tall buildings without actually measuring them in real life. We can calculate where a stone will hit the ground if thrown with a known speed and angle. It is said that Thales measured heights of pyramids using proportions. But before we come to a triangle, we need to know something about angles. Say we have a point and a circle around it. Radius is simply the distance between center and the circle. Angle can be imagined as the amount of mouth opened by the two arrows. We have this green dot traveling on the circle. What is the distance covered by the green dot as it travels from angle 0 to angle theta? That is, what is the length of the green curve? It is simply radius times angle r theta. Simple enough? But here's the catch. The angle theta is not ordinary. It's not in degrees, but in radians. What's that? If you are given a line, you can find the length of the line both in inch and centimeter using a ruler. Similarly, for a given angle, you can measure it both in degrees and radians. Let's use what we already know. The circumference of a circle is 2 pi r, which is the arc length when theta is 360 degrees. Which means 360 degrees is the same as 2 pi radians. We use this knowledge to jump from degrees to radians and vice versa. Once again, to measure temperature, we may use Celsius scale or Fahrenheit scale. Similarly, to measure angle, we may use either degrees or radians. On the scale of degrees, as we go from 0 to 360 degrees, we go from 0 to 2 pi on radian scale. 180 degrees is the same as pi. 90 degrees is the same as pi by 2. 270 degrees is the same as 3 pi by 2. 45 degrees is the same as pi by 4. 30 degrees is the same as pi by 6. 60 degrees is the same as pi by 3. Since pi by 3 is close to 1.04, 1 radian is less than 60 degrees, 57.29 degrees to be exact. We'll need angles in radian frequently, that's why it's better to learn the common angles. For this reason, we'll put them in front of your eyes enough times. We can remember the formula of arc length using the circumference formula. Put arc length in place of circumference and theta in place of 2 pi. Since when theta is 2 pi, arc length is circumference. Now, as we increase radius, arc length will increase. The first circle has radius shorter than the second, hence keeping the angle same. First arc length is less than the second arc length. As r increases, arc length increases. This time, radii of both circles are the same, but angle at the first circle is greater than angle at the second. Now, the first arc length is greater than the second arc length. As theta increases, arc length increases. Again, from the circumference formula, we know that 360 degrees is the same as 2 pi radians. We can use this to switch from one scale to another. Let's see how. Basically, we use the formula to make what we want. Similarly, let's find out how much degrees make 5 pi by 12 radians. To conclude the video, here's a question that will help improve your understanding. Solving this will help you appreciate why we chose to define radian scale the way we have done, that is from 0 to 2 pi. Imagine a car runs on a circle of radius 1 meter with speed 1 meter per second. After traveling for t seconds, what angle does the arc travel by the car make on the center? How much time does it take for the car to travel to a full circle?